Hello students, welcome to Chemship. Today we are going to discuss about one of the interesting topics, that is alcohols, phenol and ether. In this session, I am going to discuss about introduction of alcohols, phenols and ether and along with classification and nomenclature. So let's get started. First of all, introduction. Let us know how to form alcohol and phenols from hydrocarbon, that is alkane. For example, I am taking a alkane, that is RH or ARH. If I replace this hydrogen with OH, then my alcohol will form or phenol will form. For example, if I take a aliphatic hydrocarbon, that is aliphatic group is this R, and I am replacing one of the hydrogen with OH, then my alcohol will form. When I take aromatic group and I replace one of the hydrogen with OH group, then my phenols will form. In this way, alcohols and phenols form. So let us see how ethers are formed. In alcohol's case, I am replacing hydrogen with OH. In ether case, I am replacing the hydrogen with any alkoxy or aryloxy group. That means, for example, here OCH3 is alkoxy group, or if this CH3 is replaced by phenyl group, that is phenoxy group. That is the example of aryloxy group. If the hydrogen of alkyl or hydrocarbon is replaced by alkoxy or aryloxy group, then ethers will be formed. In this session, we will going to discuss about alcohols, phenol and ethers. Let's start. So our next topic is classification. Here I am classifying alcohols, phenols based on number of OH groups present in the molecules. For example, if one OH group is there, then it is called monohydric. Mono means one, hydric means OH group. Means monohydric means one OH group is there. And next one is dihydric. That means di means two, hydric means OH. So in dihydric compounds or dihydric alcohol, two OH groups will be there. So in trihydric alcohol, three OH groups will be there. Here I provided the examples corresponding to mono, di and trihydric compounds. In first one, the propanol, one OH group is there. So it will come under monohydric alcohol. In second case, it is 1,2 ethane diol. That in this compound, two OH groups are there and adjacent carbon. So it will come under dihydric alcohol. The next compound is 1,3 propane diol. In this compound, two OH groups are there. So it will come under dihydric alcohol. Yes. In next compound, that is 1, 2, 3 propane triol. In this compound, three OH groups are there. So it will come under trihydric alcohol. In next compound also, three OH groups are there. So it will come under trihydric alcohols only. Here, I didn't provide the example to polyhydric compound. Can you tell me any example related to polyhydric compound that we use daily in our food? That is glucose and fructose. In glucose and fructose, many OH groups are there. That is an excellent example to polyhydric alcohol. Okay, classification based on number of OH groups is over. Let us see another type of classification. We can classify monohydric alcohol further into three different types. That is primary, secondary and tertiary. In these three types of alcohol, the OH group is attached to primary, secondary, tertiary carbon respectively as depicted below. Primary alcohols, the carbon atom that attached to the OH will attach to only one carbon, or it won't attach to any other carbons. In secondary alcohols, the carbon atom which has OH group will attach to two carbon atoms at a time. In tertiary, the carbon atom which has OH group will attach to three carbons at a time. So this type of classification will apply to only the carbon which is sp3 hybridized. Let's go into other types. Allylic alcohol. This allylic alcohols term is very important in exams. The example of allylic alcohols is T 2 in 1 ol, and here another example I provided is cyclopentene 1 methanol. What this allylic alcohol means? So read here, in this alcohol, the OH group is attached to sp3 hybridized carbon. The OH group is attached to sp3 hybridized carbon adjacent to carbon-carbon double bond. Adjacent to this carbon is adjacent to carbon-carbon double bond, right? That's why it is called allylic alcohol. So what I am telling is the carbon atom which attached to OH should attach, this carbon atom should attach to sp2 hybridized carbon atom. Sorry, adjacent to this carbon, one double bond should be there. In this example also, the OH group here attached to this carbon, right? This carbon attached to double bonded carbon. So it is also example of allylic alcohol. In next type, benzylic alcohol comes. In this alcohol, the OH group attached to one sp3 hybridized carbon, and that will attach to sp2 hybridized carbon only, but it is aromatic. So benzylic alcohol means this. So next jump into another type of alcohol, that is vinylic alcohol. In this type of alcohol, the OH group is directly attached to carbon having double bond. This is very much unstable because the name of this compound is ethanol. The compound which is having enol part will exhibit enol tautomerism. So it is very unstable. It will convert into corresponding aldehyde, that is ethanaldehyde. Next, let us discuss about phenols classification. Phenols also classified based on number of OH groups. In monohydric phenol, only one OH will be there. In dihydric phenols, two OH groups will be there that attach to aryl group. In dihydric, the three OH groups will attach to one ring. Next, ethers. So in classification of ethers, we will importantly see about symmetry, whether it is symmetrical or unsymmetrical. For example, here I provided CH3OCH3. This is a dimethyl ether, and CH3CH2O CH2CH3, that is diethyl ether. Here, if I cut through O, it will separate equally, that is CH3 will cut equally, share oxygen equally, right? So this part is symmetrical to this part. That's why it is example of symmetrical ether. Here also, if I cut like this part and this part are same, symmetrical. Looks like a symmetry is there. So it is also example of symmetrical ethers. Let us come to unsymmetrical ethers. In unsymmetrical ethers, if I cut through this oxygen, they won't share equal. The parts which are separated won't look like symmetrical parts. That means if I cut here, the C2H5 won't look like as similar as CH3. That is not similar to this one. No. That's why it is called unsymmetrical ether. In this case also, CH3 won't be similar to C6H5. So these two are examples of unsymmetrical ether. So by the way, the name of this compound is ethyl methyl ether. Ethyl methyl ether. The name of this compound is methyl phenyl ether. Okay, let us come to nomenclature part. First, we can name alcohol. The common name of alcohol is derived from its alkyl group by adding a word alcohol to it. For example, this is methyl alcohol. The methyl part is coming from the parent molecule, that is methane. I am replacing methane with methyl. I am adding a word called alcohol. So it is common name of this one. If we go for IUPAC nomenclature, we use OL, this OL suffix at the end of the name. For example, here I am taking this CH3 group and this OH group. This CH3 group is coming from the parent molecule methane, that I am adding suffix OL. So OL. In pronunciation, we will replace this E with this OL. See, in this name, methane is same. They replaced E with OL, right? So resulting name is methanol. In this example also, the parent chain is propane and we are adding suffix ol by replacing this E. It is as simple as like this. Propane 1 ol. Next one is, what if the position of OH is changes? For example, in previous case, like this, the OH group is at terminal position. Now, in this case, the OH position is at second carbon. From here, if I count 1, 2, 3, from here also, if I count in reverse way, this is 1, this is 2, this is 3. In every case, I am getting this carbon count as 2. So, how to name this compound in IUPAC way? In that case, we can indicate the position of OH with numerical number like 1, 2, 3, like that. In this case, the OH group is present at second carbon. So I will write this is propane, no, parent chain is propane. So this is propane. The position of OH group is 2. I am adding ol as a suffix. So this is propane plus 2 plus ol, that is equals to propane 2 ol or 2 propanol. If we come to this example, let us start giving number. This is 1, this is 2, this is 3, this is 4. If we number in reverse way, this is 1, this is 2, this is 3, this is 4. But if we follow IUPAC rules, how to give name which have small numerical number. If we count in this way, if we can get 2 here. If we count in this way, in reverse way, we can get 3 here. We have to choose in this way only. We have to count in this way only. In this way only, we are getting the lowest numerical. Okay. So our position of OH is fixed now. That is 2. What is parent chain here? Here parent chain is butane. So my name starts with butane plus the position of the OH is 2 and my OH group have suffix name OL. So its name is butane plus 2 plus ol, that is butane 2-ol, or we can easily pronounce it as 2-butanol, 2-butanol. Here if we come, the parent chain is 5-membered one. That is 1, 2, 3, 4, 5. Let us count the position of this OH group. 1, 2. So the position of OH group is at second carbon. The parent chain is pentane. Let's start giving the name. Pentane plus the position of OH is second. So 2. Pentane plus 2 plus alcohol 2-ol, pentane 2-ol or 2-pentanol. Here, this is also a five-membered one. 1, 2, 3, 4, 5. The parent chain is five-membered one. So parent chain name is pentane, that is fixed, plus the position of OH, that is 3, 3, plus the functional group is OH. So the suffix name is OL. So in final, pentane plus position of OH is 3 plus ol. The name of this compound is pentane 3-ol or 3-pentanol. In this compound also there are 5 carbons. 1, 2, 3, 4, 5. 5 carbons are there. OH group is there at one of these carbons. How to calculate in this cyclic form where the OH position is there? This is a functional group now. We have to give preference to this one. So it is 1, 2, 3, 4, 5. So it is cyclic ring. So we have to add cyclo. This is pentane, no? Pentane. The position of OH is 1. So 1 OH group. So it is ol. So cyclopentane 1-ol, or we can remove 1 and we can add ol to pentane. So it will become cyclopentanol. We completed the nomenclature of alcohol. Let us go to the nomenclature of phenols. Phenols, these are the simplest hydroxy derivatives of benzene. Phenol is the simplest hydroxy derivative of benzene. That means in benzene, one of the hydrogen is removed by OH. Then it is called phenol. If I substituted another hydrogen with CH3, then it is called cresol. If I substituted, now in this case, I substituted the hydrogen that is adjacent to this OH group, right? Now I am substituting the hydrogen which is not adjacent, but the position is at second carbon from this OH group. In that case, I will call it as metacresol. That means this CH3 group is at meta position to this OH group. In this case, the OH group is at para position, so it is paracresol. Okay, let us go and give the names to it. This is phenol. Simply, the common name and IUPAC name is phenolone. In this case, the OH group, the carbon containing OH group will be preferred and it will be given as 1. And the carbon next to it is 2. This is 3. This is 4. This is 5. This is 6. So, this is benzene ring now. We can, this is first carbon, this is second carbon. At second carbon, at second position, the methyl group is there. So we can add 2-methyl. This is methyl group at second position. So it is 2-methyl. This whole group is phenyl group, no? This group, no? This one. So it is 2-methyl phenol. If we come to this is first carbon, this is second carbon, this is third carbon. At third position, methyl group is there. So it is 3-methyl. This group is phenol, no? So it is 3-methyl phenol. Like this, this is first, second, third, fourth. At fourth position, CH3 is there. So it is 4-methyl phenol. Dihydroxy derivatives of this benzene are given here. The common names and applications of these 3 molecules very, very important. Note these 3 as important. This is catechol. That means 1,2-dihydroxybenzene is called catechol. This is resorcinol. That means 1,3-dihydroxybenzene. That is resorcinol. 1,4 benzene diol is called hydroquinone. These 3 common names are very, very important frequently asked in the exam. So mark it as important, these three. Next, if we go to ethers, the common name of ethers derived from its alkyl or aryl groups. Here I wrote some examples. First one is this is CH3, that is methyl. This one is CH3, that one also methyl. So two methyl groups are there. Methyl, methyl. So two methyl groups are there. So I can call it as dimethyl. Di means two, methyl means methyl group. Dimethyl. This functional group is ether. So I will add suffix ether. This is the whole name is dimethyl ether. Here the C2H5 means that is ethyl. Here also C2H5, that means ethyl. This is ether group. So two ethyl groups along with ether suffix, that is diethyl ether. Here methyl group is there, propyl group is there. So I am naming this as a methyl group and N-propyl group ether. So methyl, N-propyl, ether. Let's come down. This is C6H5, that means phenyl group. This is CH3, that is methyl group. So I am naming this as a methyl, phenyl, this ether. So the final name is methyl, phenyl, ether. These are also according to UPSC name, but these are different from this. That is, this group is methoxy group. In this case, this is ethoxy group. In this case, this is methoxy group. In this case also, it is methoxy group. This methoxy is attached to the parent name. This is methane, right? So this is methoxy methane. This is ethoxy. This is ethane, no? So this is ethoxy ethane. This is methoxy, no, that attached to propane. So it is methoxy propane. Here methoxy group is attached to phenyl, no, that is benzene. So methoxy benzene. I think this is the end of the video. Hope you enjoyed. If you have any doubts, let me know in comment section. And please like, share, and subscribe, and share with your friends. That's it. Thank you.